Geeks, welcome back to BiharGeeks. So today we will solve a very interesting problem, that is binary tree problem, where we will identify the average of the levels in a binary tree. So in this example, what we have to do, we have given a basically a tree where we have to return a list of each level, the average. Okay, so here it's only one element is there, so we just simply divide 3 divided by 1, that is nearly equal to 3 only. Okay, in the next level there is two elements, and when we add of the 20 and 29, it will be nearly equal to 29. Okay, and we have to divide by 2 because there are two elements, so that will the average is nearly equal to 14.5. Same so on we have to do it. This example is exactly same of this. The difference is that the child node is here present in the right side and here in the left. Rest of the things are same. As you see that the result is exactly same, it doesn't matter the things are present in the right or left. We have to do the averaging at each level only. Okay, so what two things we have to maintain here. First is the sum of the node at each level, and secondly we have to count the node at each level. Okay, so let's get started with the code. As tree is already implemented here, we just simply have to write the actual code. So to write, we have to start. So first I'm going to I'm defining the list where we will store and count the number of nodes at the each level. Okay, I'm keeping it at the side, private. Hmm, list of, it will be list of double only. Okay, and here I'm keeping list of sum. It is equal to new array list. Fine. See, we have to create for the count also. I'm just copying it and change the name of it and name it as count list. Fine. Fine. Now we'll move to the actual code. So first, what we have to do, as we are working on the recursion, so maybe the recursion has happened at the one time, and this sum list and count list may contain some values from the previous, so it will impact the result. First we have to clear it. Okay, the sum list dot clear, clear, and same we have to do it for the count list also. Fine. So using this step, we will clean the previous result before starting. Okay. Now we have to start the recursion traversal from the level 1. Okay. So here we have to do, we'll create our own method that we call it as DFS. Okay. We'll use the concept of DFS only. Inside this, I will pass the root and the 0th level. Okay. Fine. And after this, whatever we get the result, we have to compute the basically average of each level. Okay, so I will keep it a result here where I'm keeping the type as double. Okay, maybe double and keep the variable name as result, that is equal to new array list. Fine. Now I have to iterate. Put the sum list, whatever the sum list we get it, and then we have to do the average of it, whatever the calculation we get it from there. Okay, so int I equal to 0, and I will move till the sum list have a value dot size. Okay, and I plus plus. Now what we have to do, we just simply have to add the result dot add, where we will have a sum list get I, and we have to divide by the count list we have get it at the ith. From here we will get the average. Basically, we what we are doing here, sum divided by the count. Okay, and we just simply return the SULT result, and we have to return it. Um, right, this is done. Now we are done with that. Now we have to define this one. So okay, from here we will drivers DSA. So this is for the traversal case. Static void DFS, and inside that we need tree node, and another will be the level. What level we are going right now? Right now, inside this, first we have to check the base case. Okay, so okay, I didn't put the name of this. I'm keeping it as node here. Okay, first we will check node is equal to null or not. If it's null, we just simply return from here. Okay, otherwise we have to like put a condition here. If level is equal to the sum list dot size, it means we move to the last. So from here we just simply put the default value inside it. Okay, so in exactly same we have to do with the count list. At 0. Right, this is done now. After this, if we are not reaching to the end, so in that case we have to update the sum and the count for the current level. So sum list dot we will set level comma sum list dot get level, and we have to plus with the node value, whatever the node value we have right now. Okay, this way we will get the sum up of the current level. Okay, same we have to do it with the count. I'm just copying from the previous paste. Mhm. Count list, here we will have a level, and instead of sum we will have a count list level, and instead of the value we need a increment here. Okay, this is done. Now we have to recursively call the left and the right child. Okay, so we just simply call DFS, and inside that we will put node dot left comma whatever the level we are right now, we just add, and same we have to do it for the right also. Paste, and here I'm going to put right. So this is done now. Let me run this. But I'm getting compatibility issue. I have defined here. Okay, let me put it in teacher. And let me run this again. Okay, it's got accepted. Let me submit this. In it's got submitted. So we have uses two lists here. One is sum list and second is the count list. Sum list basically used to sum of the node at each level. Okay, and count list is basically store the count of the nodes at each level. Okay, and we have created a one method that is DFS. So it's for basically traversal only. If it's the first value of of a level, so we initialize the sum and count, and if we add the node value to the corresponding level, so we increase the count, like which we have did at the line number 43 and 44. Okay, and we increment that count level, and then we recursively call the left and right. Okay, so if we're talking about the time complexity for this case, so since each node is visited once only, so the time complexity is O of n only, and the space complexity, if talking about, it's O of h only, because h is the height of the tree, whatever the height we have, based on that we have to use the space. Okay, so that's all for today. Okay, and if you found this helpful, smash the like button and drop a comment if you found any question, and subscribe to BiharGeeks for the more DSA, Java, and system design content. See you in the next time. Bye bye.